Hello, everyone. Welcome to this training webinar. My name is Bruno Vicenzi. I'm from the European Powder Metallurgy Association, and I'm the dissemination manager for this project called REPTiS that has organized this session. If you have come to this video, it's because you were looking for the footage from our webinar, which was held actually on the 6th of November. And you can see here the starting slide of that session. Unfortunately, the footage for that session went lost due to the IT issues in the provider on the platform where we hosted the webinar. And so we are obliged now to record the presentations again, just to let you have them, so that the information that has been given publicly in that occasion is not lost. And yeah, so I will be opening this virtual session, let's say, following the program that we had originally. So I will give you a short presentation myself about the project REPTiS in the next minutes, and then you will be able to follow the rest of the presentations of the lectures that we had on that day, on that Thursday, 6th November 2025, and starting from Artem Yarovinsky from Velta Mining, who will be presenting about the mining of ilmenite, especially linked to their example that I will be showing in the Birzulivske deposit, which is in Ukraine. And after the presentation from Artem, there will be also the possibility to see the presentation from Michael Lechner from the Montanuniversität Leoben in Austria, also participants of the REPTiS project, also dealing with the mining side. So this session, in fact, is titled Mining and Beneficiation of ilmenite-bearing heavy mineral sands, as you can see. And he will focus on the beneficiation of the ilmenite-bearing heavy mineral sands taken from Birzulivske, and let's say in general, what could happen when you try to beneficiate the sands. This is the program for that we had that day. Of course, there were question and answers, and it will not be happening here live, but of course you're welcome to post questions under the videos, or even ask directly to us. If you go to our website, you can find the contacts. You will probably refer to me or to the coordinator, and then you will be answered as soon as possible. Yeah, and don't forget to subscribe to our channel if you want to be informed about our next activities and see the next videos that we will be preparing. So, this ends my introduction and brings me into the actual first slide of my presentation about the actual project REPTiS. What is REPTiS? It is a Horizon Europe project. You probably know about the Horizon Europe funding scheme. It's been funded in 2024. We started on 1st September, so we passed already this year, the first year of activity, and it's supposed to last 4 years. You can see also the total grant is above 7 million. And we, as European Powder Metallurgy Association, are the coordinators. Particularly my colleague Kenan Boz is the coordinator for this project. You can see the title there, but rather than reading the title, you will understand what we are going to do by seeing the next slides that I'll be showing. And first of all, why titanium? Well, titanium is considered a critical raw material. It is not too much because of its supply risk, although the valuation maybe might have changed over the years, and the risk might have been considered to be increased. But especially because of its economic importance, the x-axis, as you see there, the titanium metal is one of the critical raw materials more on the right side of that chart. And yes, so it is really important for the European Union because there are a lot of products made of titanium that are being produced in Europe. On the other hand, Europe is not a real producer of the raw materials. And practically all of the titanium which is used in EU, in aerospace, of course, in industrial applications, but then in defense, and we know that defense is on the, let's say, on the growth side now, and medical. This is all imported, basically. There is hardly any usage of ore from a European land, and due to several reasons. And even when we receive the ore, we are not actually receiving as an ore, but already in the sponge state. The production of sponge that you can see on the left is virtually missing any European partner, unless you consider Russia as part of Europe or Ukraine as part of Europe. Those are both visible in that chart, which goes until 2023. What happened then? And in practice, the EU production of ingots as well is well below 5%. So it means that we even import more than 95% of the ingot of titanium. Right. So the geopolitical conflicts then complicated the situation, and you can see here on the right a chart coming from Eurostat COMEX that shows what happened before and after the variation in tons, in kilotons of imports of titanium metal from the different sources for Europe. And you can see that, Russia, of course, was penalized. Ukraine was very penalized, both in wrought and unwrought, and even the imports from UK were damaged. So imports from other countries like Kazakhstan, China, and Saudi Arabia, and Japan, especially, and Japan and China in the different situations have increased, and also US. So the supply chain for Europe is a bit critical, and this doesn't surprise us. So this is let's say, the y-axis in the critical raw materials chart that we saw in the previous slide. So it's even got worse, as we said. So the idea was to try to overcome this, and the EU already had started to have a strategic partnership with Ukraine for many reasons, but also because it's a very important partner in terms of availability of critical raw materials. And so the idea was to respond to the call of the Horizon Europe framework to establish a supply chain from one of these strategic partner countries. The other one possibility was Canada. We chose to follow the Ukrainian track, let's say, and set up a consortium to try to establish a sustainable and energy efficient solution for extraction, processing, and finally sourcing of titanium into the EU. And here we'll be focusing in practice on titanium powders, which is, for the European powder metallurgy, clearly one of our goals. So we have a lot of participants that you can see already in the map on the right, 13. We are the coordinators, and the other data you already seen in the previous slide. Better look into the consortium. You can see on the left the roles of the partners, starting from mining, then processing of the titanium ores, and then characterization and validation of the powders that we will produce. And then there will be a functionality assessment on some components that will be produced. So we need industrial partners for that. The evaluation of sustainability of the process developed. And of course, there's also some management that's done by the coordinator, and the dissemination and communication that is also done by us. You can see it also better explained in the chart on the right, where you see a sort of flow. It all starts from ilmenite being supplied from Ukraine in the mines developed, owned by Velta. And then Velta R&D Titan is actually doing the processing into metal powders. And all this is done with the support of Montanuniversität Leoben and Technalia. The Velta process is able of valorizing also byproducts. We will see it in a bit more detail later. But in particular, we will process the titanium into titanium metal powders that can be used in different advanced manufacturing techniques, powder metallurgy techniques. And we will first characterize the powders, and then this can be done by the several research centers that we have in the consortium. Technalia already mentioned, Leoben, Hereon, and Fraunhofer in Germany, both specialized in powders and in titanium. And then we can have the two, in particular, two processing routes for manufacturing of parts. Our product will be the powders, but the parts will be used to assess their viability for actual industrial processes. So these processes are metal injection molding, which is one of the powder metallurgy techniques that can be used. And here we have two companies, one in Germany, Element 22, and the other one in Spain, Alpha Mimtech. And then there will be additive manufacturing, metal additive manufacturing, laser powder bed technologies. This is done by IAMG in Poland, which manufactures machines and components. And by University West, who is the partner that will be developing especially the aerospace parts. And here we will have also a relationship with GKN Aerospace, which is clearly which is an associated partner and is clearly linked to University West and aerospace validation. So what is the situation at the moment when we're talking about production of titanium powders? And this is a starting point, which is showing many weak points. I mean, there are very established processes. There are also other processes established, and some of these will be shown later in the other lectures. But in particular, we are talking about the so-called core process that starts from the mineral, and here we have the ilmenite. So there is a melting process. There is a chlorination to separate the titanium, and then this titanium chloride is reduced into a titanium sponge, which is then this is done by reaction with magnesium, so that the chloride is then recycled in the process. But after that, you have to remelt several times this sponge of titanium to obtain the right composition. Also, you have to add the various alloying elements if you want to produce the different titanium alloys. And then you have to produce the powders, you have to go through an atomization. And as titanium is very reactive, this has to be done in a very special process called, normally is done in a process called EIGA, which is electrode induction gas atomization. And this brings to finally the spherical titanium alloy powders. During all this process, which is lengthy and highly energy intensive because of the several meltings, especially, there are also a lot of streams of waste, in particular calcium or iron containing waste, that chloride containing waste, that they sometimes end up in landfills. Whereas some parts are recycled, like the magnesium. Clearly, the whole process is working. It's definitely the workhorse for titanium production, but it has a high level of carbon footprint. And the good starting point for the project was that Velta already developed a process called Velta titanium process that is already has already a lot of advantages that you can see on the left, and we will comment. So here, if you start from the left, from ilmenite, then you can have just by chemical processing, you can have the separation of the titanium fraction, which is the syngrotile, which can then be reduced with similar processes to those used in the crow process, if you want, also by usage of other, let's say, stripping metals like magnesium and calcium. And you can finally get to the crude titanium metal, the equivalent of a sponge. But this is done then just crushed into a powder, an irregular powder. Please note that while processing the titanium ores, they can already be additivated with the other alloying elements, and this leads to the direct formation of the alloy sponge, which is then crushed into the titanium alloy powder directly without having to alloy in the melt. So as you can see, it's a low temperature process already compared to the several meltings in the crow process. And on the other hand, Velta already developed all the valorization of the side streams. So all the waste, which is everything which is not titanium, is either recycled, like for instance, the sulfuric acid, it's reused in the process, or used as other products for several applications. You can see there's pigments, there's flame retardants, there's materials that goes into construction materials, and also in the fertilizers, for instance. So actually, it's a zero waste process. And so we can claim what is written on the left, that there is avoidance of solid and liquid waste generation, finally a reduction of the carbon footprint because of all these possibilities, and an improved particle size control and homogeneity in the powders. This also means a significant reduction of the cost of the finished products finally. Also, I want to mention that we normally reach with the process the irregular shape of the powders, which is used only in some technologies. For other technologies, you need to have spherical powders, but that's also possible by post-processing, spheroidization in particular, which can lead to the creation of spherical powders, which are more flowable for some of the powder metallurgy processes that we will also need to use in the validation and finally in the exploitation. Here we already have some preliminary data concerning the energy use, the carbon footprint, the waste management and powder quality summarized. And here you see some figures, and you can see that the advantage in terms of energy use and finally of carbon footprint is quite remarkable. And we hope we will be able to confirm this or even make it a little bit better, who knows, during the scale up of the process. Yes, because clearly we need to go from what we already have, which is already available at, let's say, lab scale, at kilogram scale, to a higher amount and achieve TRL 6 or 7 at the end of the project. And we want to demonstrate that this improved process will be able to replace, at least partially, the Kroll-IGA process. And well, all starts from Ukraine, and here you can see some images from Birzulivske. You can see the sands there that are being exploited, and then some of the processing that can be done on site. And then also in Ukraine, there's the facilities that will process the ore into the actual metal powders as shown in the previous chart. So we plan to build this supply chain from Ukraine, and this will likely be one of the good sources for titanium to be used in powder metallurgy products in Europe with this net zero waste approach and with the sustainable production, and so that producers will be able to claim lower end values of their sustainability indexes by using a more sustainable feedstock. We plan to apply the powders in different use cases, and these are coming from different technologies, as I already mentioned: metal injection molding, metal additive manufacturing, and this will be useful to validate the powders and finally raise the awareness for them. And we hope to establish a good market acceptance for the new powders. Here are some examples. The sectors that we're aiming at are medical, aerospace, consumer goods. You see there some additively manufactured parts. The one on the right, the bottom right, is metal injection molded. So we will see all these applications, and we're not planning of doing a full characterization, full validation of these components in the final use. That's beyond the scope of the project, but because the product is the powders, but these will be the validation of the powders in a real industrial use. Right, so finally, we will also compile LCA datasets for the titanium powders and the products that we'll have, a product environmental footprint study for the 4 case studies. And yes, where are we after almost 1 year? I cannot give you details right now, but the work has been focused on the titanium extraction and optimizing that by making it more sustainable with use of green energy, for instance, and optimizing the processing for the concentration into what you can see on the bottom right, which is one of the batches of alloy powders alloy precursors, let's say, that have been moved from the mine to the processing plant for the production of first batches of alloy powders that are going to be distributed among the consortium right now and undergo the first tests. So we'll keep you informed on what happens. Finally, let me just thank you for being here, for following this presentation, and I want to remind you that we have a website that you can consult anytime you want. We have LinkedIn and X social media accounts where you will find news about us. Please follow us on these web social accounts and website. And of course, you are seeing this video, so you already discovered our YouTube channel. So I'm sure you will subscribe to it to be kept informed. And yes, now you are very welcome to follow us through this webinar, or let's say refurbished webinar. Please follow the presentations by our 2 lecturers. Mine was just an introduction. The ones that you will follow will be more in the shape of lectures. So there will be Artem Yarovinsky, as mentioned at the beginning, and Michael Lechner, and you can find the videos also here on this channel. Thank you again, and see you in one of the next webinars. Hopefully, we will have other a whole series of training webinars, always free, and in addition to all the other events that the project is organizing, where we'll be speaking and disseminating, communicating about our project. But I hope to see you again in a live session with us, and maybe with possibility of exchanging opinions and questions and answers. Thanks a lot. Have a nice day.